equals to y raised to power 1 minus z. N is the highest power of y, is the highest degree of y that you find in that equation. For example, this one now, n is 2. Okay? So, we want to differentiate y raised to power minus 1 with respect to x. Z and y, they are functions of x. So, the z dx with respect to x, we have y squared is same thing as y minus y squared is same thing as y minus 2. 1 over y squared is same thing as y minus 2. So this is going up. So we have something like y minus 2 dy dx plus 1 over x. If this comes to if this comes up, we have this 1 minus 2. Do we get that idea? Equals to x. Y squared cancel y squared. So we have a function like this. Now the next thing you are going to look for is that z equals to y raised to power 1 minus 1, abi? This is our z. So we can basically see z here. Now z dx. So whatever is in front of this, which is minus, we multiply this equation through by it. Y dx, abi? Whatever is in front of this, which is minus. In this case, it is minus that is in front of this. We multiply it through by, we multiply this equation through by that.
Clean separable variable.
It's getting longer. Like what I just want to do is that I want to make sure the y, this the z dx is here. I want to make the z dx here. But the z dx equals to this minus y minus 2 dy dx. But it's only this part that I have here. It remains this minus. Do you get it? It remains only this minus to make this complete. So I multiply everything through by minus. It does not change the equation at all. Now look at this. Minus y minus 2 dy dx minus 1 over x y prime minus y minus 1, sorry, equals to, do you get what I did here? So now I have the z dx here. This is my z equals to this. So I can now rewrite this in terms of z. Z prime minus 1 over xz equals to minus x. We can now use it to solve this. So let's finish this up. Please, if you don't understand, let me know. This. I'm still going to e raised to power integral of this, integral of minus 1 over x, which is e raised to power minus ln x, as x minus 1, so we are multiplying x minus 2, minus x minus 2. Let me write it out so it won't confuse. This is minus x minus 1. So I'm multiplying it by x minus 1, and z is in front of it, equals to minus x dot x minus 1. I'm multiplying through by x minus 1. So I have something like x minus 1 z prime minus x minus 2z is equal to 1 minus 1. Am I correct? This is x, this is minus 1. 1, x raised to power 1, 1 minus 1, 0, 0 here. X raised to power 0 is 1. So I have this now. X minus 1, z prime. Z prime is the same thing as 0, and the z dx, So we said after using integrating factor, this side is going to become x minus 1. You just pick your z, remove this prime from it. That's how it is. You have to compare. In case you have something like trigonometric functions, you have to compare. So equals to integrating minus 1, we have minus x plus c, right? So it means z equals to, I'm multiplying by x now. So as to take this away, this is z over x equals to minus x plus c. The same thing. So multiplying by x, I have z equals to cx minus x squared. This is same thing as c minus x. So multiplying these two by, I have z equals to cx minus x squared. So I now bring in my initial z equals to y minus 1, Abi. So bring it back here and say y minus 1 equals to cx minus x squared. So y equals to cx minus x squared minus 1. And that's all. So we have found the solution to the first Bernoulli equation. It's only long, it's not a problem. So the first step is just to make sure it's in this exact order, so that you can know what your n is going to be. So after I found our n as this z, our n here is 2. So our z is going to become y raised to power 1 minus n. Our n here is 2, so our z equals to y 1 minus 2, which is y minus 1. Then you now find your dz dx. This z dx, z prime equals to, you differentiate this. Minus will come down, minus y minus 2 y prime. You are differentiating it basically. So if you compare it to what is in front of this one, you will see that minus is missing. So it's this minus that you use to multiply it. Once you multiply it by minus, you are going to see your z prime. You are going to see your z. So you just transform everything. Everything will be transformed into this kind of equation that we can solve with integrating factor. And that's all. And that's all. You don't understand this? Can we go to the second one? Can we go to the second one, please? Can I finish this? After this, just going to second level. Second level, junior, second level, junior. You cannot teach Russian business. Russian.
Yeah, I think so.
Because it's
Well, I got the rest of it.
if you want to solve non-homogeneous, you can use variation of problem. Variation of problem cannot be used. Can I finish?
Okay, let's one more question. Yeah. Sure. Can we see the board? Those who are watching online. Can we see the board?
So I can think now. I can think. Can I?
All right.
Now look at this second one. It's not in Bernoulli form yet. It's not in Bernoulli form yet. So the first thing you are going to do is just make sure your y prime is standing alone. Let's rearrange this.
Yeah, correct. Into video.
Minus x cubed y prime plus x squared y equals to y raised to power 4 cos x. Let it stand alone. So we are dividing through by minus x cubed. So we are going to have over minus x cubed over minus x cubed over minus x cubed. So this is gone. So we have y minus this 1 over x, 1 over xy equals to y raised to power minus y raised to power 4 minus will be in front cos x over x cubed. I can also bring it up and say x minus 3 cos x. It's the same thing. So this is the Bernoulli form, and our n here is 4. N equals to 4. So z equals to y raised by 1 minus n. This is substitution we are using. So the same thing is equal to y 1 minus 4, and that is y minus 3. So this is the substitution we are using for as z. Z equals to y raised by minus 3. Now let's differentiate. The z dx equals to, differentiating this, we have minus 3y minus 4 dy dx. Abi? So now let's go back to our initial equation. So what do? The first thing, we divide through by y raised to power n, which is y raised to power 4. So we have y minus 4, right? I'm dividing through by y raised to power 4. Y prime minus 1 over x. Y is already here, so this is 1. So if I remove 4 from it, so it's going to remain minus 3. Abi? It's going to remain minus 3 equals to minus y raised to power 4 will cancel out. So I can bring this one up and say minus x cubed, x minus 3 cos x. Please, you understand how I did it? Now looking at this, you can see this y minus 4y prime. Y minus 4y prime, Abi? The only thing that is missing is minus 3. Do you get what I'm saying now? Please, the only thing that is missing is minus 3. So we multiply everything through by minus 3. So we're going to have minus 3y minus 4y prime plus 3 over x y minus 3 equals to plus 3x minus 3 cos x. Do we get? I multiply it by minus 3. Now, this is looking exactly like the z dx. And we have our z. Z equals to y minus 3. Abi? So we are now going to rewrite this as z prime plus 3 over x z equals to 3x minus 3 cos x. So what's our integrating factor that we're going to multiply to? E raised to power integral of 3 over x, Abi? E raised to power integral over 3 over x dx. And this gives us e raised to power 3 ln x, which is same thing as x cubed. Abi? E raised to power ln x cubed. Properties of logarithms. 3 can come to this. So e will cancel out x cubed. So we are multiplying through by x cubed now. X cubed z prime plus 3x cubed over xz equals to 3x cubed x minus 3, sorry, x minus 3 cos x. I mean, x can cancel out here and turn this one to 2. This will cancel out. So we can cancel these two of them out. So we have 3 cos x. So we have something that we can now work with. Thank you. So looking at this, if we differentiate x cubed, get 3x squared. This 3x squared here. If we differentiate z, get z prime. So this is a product of whatever. So we can now integrate both sides. Integrating this side, we have x cubed z equals to, integrating 3 cos x, we have 3 sin x, abi? Integrating 3 cos x, now make z the subject of formula. And say z equals to what? Z equals to, divided by, oh, sorry, thank you so much, plus c, thank you so much. Divided by x cubed, we now have z equals to 3x minus 3 sin x plus cx, right? So this is our z. But don't forget z is also equal to this. Z is equal to y minus 3 equals to 3x minus 3 sin x plus cx minus 3. And say y equals to this 3x minus 3 sin x plus cx minus 3. This one will now take minus 3. And that's it. Second. Is it? When coming to the other side, sorry. So this is 1 over, sorry, this will be 1 over 3. When coming to the right side, this will be 1 over 3. Sorry about that. Please, if you don't understand anything, and that's what about the nonsense. That's okay. Second order.
Hello.
Sorry.
We are starting second order. Are we still there?
Can I hear this?
Hello.
So I think those two should be more. Or 3.
All right. Please share the link with others on the group so that they can see. I don't want to leave the page to avoid transmission issue. Ebi ń pa mí o. Yes. You're writing just small. Just zoom.
Can I hear this?
Yeah, share the link. We are starting second now. Share.
We have ODs in this form. The first thing that comes to your mind is characteristic solution. You are first going to write out the characteristic equation for this one. The characteristic equation is that you are going to use the substitution equals to e raised to power rx. They also call it e raised to power mx or e raised to power x. Or e raised to power lambda x. Any of them. You can see it in any of this one. So this is the substitution that we use. Y equals to e raised to power rx. I prefer using rx, but you can see it in any of these 3 forms. So if y equals to e raised to power x, it means y prime is differentiate r a rx, right? It means y double prime, second order, r squared e rx. Abi? Now let's solve the first one using this. Number 1, we have y double prime minus 3y prime plus 2y equals to 0. Our y double prime is this. So just write it on r squared e rx minus 3, what's y prime? r e rx plus 2, what's y? e rx equals to 0. We cannot divide through by e raised to power rx. Our e raised to power x is not 0. So we can divide through and say this is r squared minus 3r plus 2. I mean, do you get what I mean? We divided through by e raised to power rx. So this is what we call our characteristic solution, our characteristic equation. So we are going to characteristic equation solutions now. Now this is minus 2 minus 1. Abi?
Yeah.
R squared minus 2r minus r plus 2 equals to 0. Yeah, exactly. So r is bracket minus 2 minus 1 is bracket r minus 2 equals to 0. So it means r minus 1, r minus 2 equals to 0. So this means r equals to 1 or r equals to 2. So these are our, what do I call it? Our roots, yeah? These are the roots of our water. So we cannot say y equals to e raised power rx. R is either 1 or 2. So let's plug it in. We can say y equals to e raised power 1x or e raised power 2x. So y1 equals to e raised power x and our y2 equals to e raised power 2x. Since both of them are solutions to this ODE, since both of them are solutions, we can add them together and say our y equals to e raised power x plus e raised power 2x. But most times they add constants c1, c2. So this is how you basically see solution. So this is solution to this ODE, to this number one equation. You just use this y equals to e raised to r, input it, and so goes the flow. Should we try some more? The values of this are will matter a lot. The values of this are will matter a lot. The best scenario is for us to have two different answers like that. How do I? If we have the same thing, we are going to use another.
Can we just write it as R twice? Like
Let's say r equals to 4 and our y equals to e raised to power 4x. This is our first what's it called? So the second will now become y2, this is y1. Y2 will now become c2, x multiplied by x e raised to power 4x. If they are 3, this is 1. If it is repeated, you know this is a quadratic, you get two answers. R equals to 4 or R equals to 4. Abi? So that's when you multiply it by. If it is a cubic and we have 4, R in 3 places. So you are going to do y3 equals to c3 x squared e raised to power 4x, the same e raised to power 4x. If it is a quadratic equation, y raised to power y4 equals to c4 x3. Can you see that? X e raised to power 4x multiplied by x, the next one x squared, the next one x2 raised to power 4x, y5 c5 x raised to power 4 e raised to power 4x. It's just like that. Just continue like that. So if it is just one single alphabet, if we have complex, we should be able to encounter one of that here. Can I change this, please? Question 2. Let me do the concept. Can we start?
yes.
Okay, so the second one we have y double prime minus 4y prime plus 5 equals to 0. So I can write this as r squared e raised to power rx minus 4r e raised to power rx plus 5 equals to 0. I don't want to jump to the you can easily write this as this is the second derivative, so it's r squared. This is the first derivative. There's no derivative here, so there's no r at all. So divide by e raised to power, so we have r squared minus 4r plus 5 equals to 0. So what can satisfy this? If it's going to give us one, let's just use quadratic formula. So we just use quadratic formula straight away. So quadratic formula says r minus b, which is 4, have we? Minus b plus or minus square root of b squared. B squared is 16 minus 4ac. Minus 4, a is 1, c is 5. That's minus 20. 4 times 5 is 20, have we? 1 over 2a. Our a is 1, so this 2. So it means r equals to 4 plus or minus square root of this is over 2. So our r equals to 4 plus or minus this is 2. Minus 1 is I, have square root. So it means our y equals to e raised to power 2 plus or minus I x. We basically don't need this plus or minus. All we need is our plus. We can use the minus, but it will still yield. So let's multiply through by. So this e raised to power 2x plus ix, right? E raised to power 2x plus ix. So what are we going to do? This is indices. We are so in indices. I can separate this and say e raised to power 2x, e raised to power ix. Abi? Now, according to Euler said e raised to power ix equals what? Sin x plus I cos x.
Okay.
No, cos x plus I sin x. Cos x plus I sin x. So this I is a constant, so we just take it as e raised to power ix. In what is it called? In ODE, we take it as e raised to power x equals to a cos x plus b sin x. So this is the first solution. It means y1 equals to c1 cos x and y2 equals to c2 sin x. Both of them will satisfy this equation. So we now go back to this and say this equal to our y equals to this, have it? So it means it's equal to e raised to power 2x into bracket e raised to power x, which is what? c1 cos x plus c2 sin x, and that's all. That's the solution of our ODE. As equals to minus b plus or minus square root of a squared minus 4ac over 2a. Quadratic formula. Why did we use it? It was factorizable. It's something that is factorized. Look at it. R squared minus 3r plus 2 equals to 0. Abi? So this one is something that can factorize into r minus 2, r minus 1. If I use it, look at what we are going to get. R equals to minus b, that's 3 plus or minus square root of minus b squared. B squared is 9, abi? Minus 4ac. 4a is 1, c is 2. So 4ac is minus 8 over 2a. So r equals to 3 plus or minus square root of 8 minus 1 is 1. 8 minus 9 minus 8 is 1. Square root of this is 1 over 2. So this will give me 3 plus 1, 4 over 2, or 3 minus 1, 2 over 2. 4 divided by 2 is 2 or 1. So I can easily use factor method. So it gives r equals to 2 or r equals to 1, which is the same thing. It's the same thing. Quadratic, you can solve quadratic using, I think, 4 methods also.
Are we following? Any issue?
We always use you, yeah. We divided it by e raised to power x. Oh,
It's the
That should be the mistake here. 5 should, y should be here.
Yes. There is
You
y.
can't add y to it.
No, there is y.
Y should be there. Y should be there. Y should be there.
There is y. Y prime, y prime, and y.
Y should be there. Sorry about that, please.
But sorry,
Yeah.
that one y equal to 0. Y prime, which is the first order, will be r. The y prime will give us r squared. So why do we now put the r at the back again? Like the y they put at the back of that line.
There is no how at the back of the 5. It's just the
That arrow means all down derivatives.
it's just e raised power
Y equals to e raised power rx. This is y e raised power rx. That's what it is. Y prime equals to r in rx. Y double prime equals to r squared in rx. That's it. So you can go through it. Sorry about that. So the third one, can we go for the third one? Let's go for the third one. Can I clean everything, please? So when we are done with this form, we just solve things that are not homogeneous.
We have slept, Abby. Where's my data? Okay.
I won't joke, you know.
This is just in my mind. Like,
Now the third one, please. Oh, you can finish it now. No, like you can finish it. Wait, okay, so you're Monday. One on Tuesday.
Back to back. What is it? Nothing on 201. Wait, is that nothing on 201?
2-1 is simpler than OD.
But when we read that woman differentiation,
Well,
calculus
it
T.
depends on
When
how-
we reach calculus T, there is something there. Calculus T.
What is calculus 3?
Bros, there is something there.
Me, I know they attend class. I know they ask me. Just one day.
All right, please let's do the third one. Let's do the third one. 3. Y double prime minus 8y prime plus 16y equals to 0. So we are going to have something like r squared minus 8r plus 16. Abi? So this is characteristic equation. So minus 4 minus 4. Now can you look at this now? Can you see this? Minus 4 minus 4 minus 8 minus 4 times minus 4 16. So basically this is r minus 4 squared equals to 0. Abi? So it means r equals to 4. Can you see something like this now? R equals to 4 or 4. So that's the two. You get R equals to 4 or 4. So we can now say y equals to e raised power rx, which equals to e raised power 4x. So my y1 will now be c1 e raised power 4x. And my y2 will now be c2 x e raised power 4x. So my total c, my final y, my final solution will now be c1 e raised power 4x plus c2 x e raised power 4x. We usually factorize this and say y equals to e raised power 4x into bracket c1 plus c2 x. So that's the solution to that. Number 3.
The question I'm asking that time is, here now we have r equals to 4 or 4.
Yes.
Can we just write r equals to 4 twice? Like instead of writing 4 or 4,
Here
we
is
just
about
put
4.
4 twice at the back. Then we can now, when we want to write our general formula.
Oh, I don't get that.
Like instead of writing 4, you just add
Yes, this is the thing. How do you go 4 twice? Yes. How is 4 into basis? So let's do the last one. Let's do the last one. It's after obliquity. After
what
obliquity.
about inverse operator?
Yeah?
Inverse operator.
It's also part of obliquity. Inverse operator is also obliquity. After that,
Undetermined
Everyone
coefficient.
will block
Agba.
There are only 2 parts we will not be able to do. Difference equations. Difference equation
Y
eigenvalues.
Y n minus 1.
Eigenvectors. This is part of
vector calculus.
so these two probably maybe we'll do it overnight. Maybe we'll do it overnight. No, it comes.
I want to record it. We send it before tomorrow.
Man.
So another thing is it remains only the last one. Please, if you don't understand, let me know, please.
Last one.
Yes, number 4.
Yes, the last one for this. So after this one, we'll not do those that are non-homogeneous. So that's why we now enter methods of determining coefficients, Wronskian. For variation of parameters, they call variation of parameters Wronskian method too. But I don't take them as single. Because there are like 3 methods you can use to solve them. 3 different methods to solve variation of parameters. It's not that you just take any method. Okay. Okay, this last one. Yeah. So we have y prime minus 2y prime plus 10y equals to 0. So if you have to write the equation of this, you have r squared minus 2r plus 10. Have we?
That's equation.
Formula. 5 and 2. R equals to minus b 2 plus or minus square root of b squared is 4 minus 4ac, that's minus 40. Oh, over 2. Can you say 2 plus or minus this minus 36 square root of minus 36 over 2. So this will give us 2 plus or minus 6i over 2. So we have r equals to 1 plus or minus 3i. So our y equals to e raised to power 1 plus 3i x. So this is the same thing as e raised to power x plus 3i x. So it means y equals to e raised to power x into bracket. Now 3ix is the same thing as what? A cos 3x plus b sin 3x, and that's the final answer. 3x. That's what we are going to use for. If you understand it. So this is the final one for homogeneous second order ODEs. Then there is one. Whenever you have an ODE, the y is not inside it. The transformation we use. Let's say the ODE does not have y is missing. So we are going to use a transformation. V equals to dy dx. Y is missing. So this V is a function of x. If x is missing, you still use V equals to dy dx. But this time around, V is a function of y. We have examples. If you have any question, there's one inside that page, or even two, or so. Now look at this one. If v is a function of y and v equals to dy dx, what will the square y dx square be? We want to differentiate v, but v is a function of y, but we are differentiating with respect to x. So since v is a function of y, our d square v dx square will now become v dv dy. This will be the. Please, can I use somebody's side? Please, can I use your page? There's a question inside.
This one I will take do live stream.
Yes, exactly. Exactly this. I can clean this now. Have you?
No.
Alright. Let me clean this.
Una sha dey waste my data. Okay. I cannot come. I will follow on YouTube. I don't see you now.
So then, you know, TikTok now, you go collect live.
What's the name?
So on TikTok, so you collect live.
What's live?
I can't use TikTok. I can't use TikTok.
What's live?
You know, see like.
I've already started monetization. How much does lion worth?
France. How much is lion? Gemini, how much is lion? One big lion. One big lion, one small lion.
Now we are doing live stream on TikTok. Now we are doing live stream on TikTok. Like what's the lion?
That's like what the universe.
Just do one live stream like lion.
You have gift cards. You have gift cards.
I also have gift cards here, but they are card. They don't give me. There's what we call super chat here, and super times rather. Can buy 400 naira, 1,000 naira.
I'm confused.
Which version is this? So these two, they are second order, sir. That's a
Yes.
Yes, we get to this one quite well. Yes, we got all these ones quite well, Abi. They don't go for now.
I don't even sabi that one at all.
We are now.
So the price of lion is $350.
Almost 100K. So looking at it now, X is here, Y is not here. So Y is missing. This one, both of them are even missing. So this one, just take it as X is missing. This one, Y is missing, X is missing. So for that, Y is missing. So our V equals to the Y, the X. But since Y is the one missing, we are going to use V is a function of X. V is a function of X. So it means V equals to the Y dx, V prime equals to what? The square Y dx squared. Have it? Just differentiate both of them.
You don't understand.
Y is missing in this equation. So the substitution we use is V equals to the Y dx. For both of them, V equals to the Y dx. But the difference is that anytime Y is missing, your V is a function of X. Anytime X is missing, your V is a function of Y. Do you get? So, since V is a function of X for this one, the V dx equals to second order. Shall we get? So this is what we are now going to throw inside this equation. Do you get? So now let's do this. So we have X, the square V dx squared is the V dx. X the V dx is just like we are reducing the order. That's it. It's just like we are reducing the order. Equals to 2, the Y dx is what? V, Abi, V squared minus the Y dx is V. So we have reduced the other now. Please look at whatever. X v prime, have you? We get. I'm still going to rewrite it. So this is everything here is in function of v, have you? Okay, let me even write it. dv dx. So I can write this as x over dx equals to 2v squared minus v over, have you? You cannot transpose or whatever. So dx over x equals to dv over 2v squared minus v, have you? So what else do you have here? We integrate both sides.
That would be 1 over x.
This is the next now. So ln x, no, let me take this to the other side. Equals to integral of dx over x. Now let's integrate this one. So for this one, we have something like integral of dv over 1 over 2 of v. I can bring my 1 over 2 out. This v into bracket v minus 1. No, partial fraction. You all understand partial fraction?
Yeah.
So I can separate this using partial fraction. Equals to, let me just write this out. In x plus c. Have we?
Yeah.
Now let's use partial fraction to separate this. So we have a over v plus b over v minus 1. Have we? V into bracket v minus 1. Have we? Av minus a plus bv. Have we? Must be equal to 1 over v into bracket v minus 1. So everything I've written up must be equal to 1. So this means a plus b equals to what? Equals to 0. Av and bv, there's no function of v on top. Minus a equals to 1. Have we? Minus a equals to 1. Here, a equals to minus b. Have we? So basically, b equals to what? We don't know how to use, do we know how to use, don't let me say we all know how to use partial fraction. We can all do this, have we? We can all do this. And we all do this. Partial. No, go for it. Should I begin from here? Or, please, should I start again? Please. A function that is like f of x over, let's say this one now, v into bracket v minus 1. It is a product. I can separate it into something like a over, pick one of the product, v plus b over the second v minus 1. Now let's join this together. V into bracket v minus 1. We have gotten what is here. So what is on top must conform to what is on top here. So this is now a into bracket. If this comes out, it means v minus 1, plus b into bracket. If this comes out, it means v, it must be equal to, our f of x here is 1, 1 dv over, must be equal to 1 over v into bracket v minus 1. So it means top must be equal to 1. So it means, let's open this. AB minus a equals to, okay, plus bb must be equal to 1. Do we get it? So we are going to bring those functions that are of v. Every function of v, this same thing as writing plus 0v. There's no v here, so it's 0v. So this cannot, I cannot say a plus ab plus bv to 0v. A plus b v equals to 0v. Cancel out. It means a plus b equals to 0. Compare the ones that are constant. Minus a is the only constant here, and 1 is the only constant here. It means minus a equals to, which means a equals to what? Minus 1 plus b equals to, a is minus 1, so I just put in minus 1 plus b equals to 0. It means b equals to what? 1. Do we get? So b equals to 1, a equals to minus 1. So I can now rewrite this integral as 1 over 2 integral of, instead of writing 1 over whatever, you now write A over what's my A minus 1 over V plus what's my B 1 over V minus 1. Everything is in dV. Integrating this one, I can bring my minus, I can't bring the minus out. So 1 over 2, I can't bring it out because this 1 over 2 belongs to both of them. Do we get this? 1 over 2 belongs to both of them. Now let's integrate through. So this is minus ln plus ln V minus 1.
Okay, yeah.
Abi?
Yeah.
Ln V minus 1. So multiply through, we have minus 1 over 2 ln V plus 1 over 2 ln V minus 1 is equal to ln X plus, I can write this one as ln C, Abi?
Yeah.
I can write my C as ln C so as to join them together and say is equal to ln Cx. Abi? Let me multiply through by minus 2, whatever, yeah, minus 2. So I'm going to have, if I multiply through by minus 2, no, let me join it together first.
Yeah.
Let me join it together. Please, if I join it together, I'll have 1 over 2 into bracket ln V minus 1 minus ln V. Please, do everybody get how I did this? 1 over 2 minus this. So I factored 1 over 2 out. 1 over 2 ln V minus ln V. Ln V minus 1 minus ln V. Please, do we?
Yeah.
Do we get it? It's the same thing.
We are following that.
Equals to ln Cx, are we?
Yeah.
Now, difference of whatever, what's it called? Difference of
Logarithm function.
logarithm. Plus, when it was plus, we turn it to multiplication. So I have 1 over 2 ln V minus 1 over
Over V.
Abi, logarithm equals to ln Cx. Abi, now I can multiply by 2. Let me multiply by 2. So this one will not leave here and come here. Abi, these two can still leave here and come here.
Yeah.
Abi, do we get what I'm doing, please? Please, do we get what I'm doing? So if everything here is equal, ln, that means what is inside is equal to what is inside. Abi, so it means V minus 1 over V equals to Cx. So do this, 1 minus 1 over V equals to what? Cx squared. I'm bringing this to the other side and this to the other side. Equals to 1 minus Cx squared. Abi, what was my V? V equals to what? V is the y dx. You are not done.
Cos RMB. No, I'm shifting this.
Please, do you understand how I got to this 1 over V? So it means 1 over V is the x dy, Abi. The x dy equals to 1 minus Cx squared. Please, if you don't understand, let me know. It's not the answer, we are looking for one. The y dx.
It will not come out.
1 over 1 minus Cx squared. Abi? 1 over 1 minus Cx squared. So it means if we integrate this side, we have the y equals to the x over 1 minus Cx squared. Integrate both sides, we have y integral of this. But there is a catch here. This minus this c is a constant. This is a constant. There are only two things that happen. It's either this c is negative or positive. I mean, if it is negative, I will have y equals to integral of dx plus cx squared. I mean, or let me just say y is also equal to this. Both of them are valid. If you can integrate both of them, fine. Should we integrate both of them?
That is not enough. So
It will not be enough at all. If you want to integrate this one, say this one 1 plus cx squared. This is that. Is it that one?
Yeah. Well, we have to.
Let's do it first.
It's 2 squared.
You just take by sense. If you know what to do next, you are fine. This if you are not saying that, let me know.
To act on that, we have to.
it will not come out. No.
Based on the score that you know, it will not come out.
I think S square alone should be there. I'm sure money. Yes, you can factor out C from the denominator. I'm a 1 over C.
Let U equals to
Check it, continue. Like that, like this now. Like this. The X over 1 plus X over C into 1 over C plus S squared. And this one can come out. S squared is still and go bust that. I'm a charge 1 over 1 over C.
there's a way to do that. Can I really do this? But we know we got this.
So we can end it. That is that will be we can end it there. It will not come out.
I go rough am.
Are we just pick you? This one is not to do that. Let's see.
Guys, you dey set it up.
One plus C X.
You not follow the example.
See why I'm going to love. Like rule, you better vex the Colomanda rule. Standard integral. Taking you out to be one answer, I will cut the YouTube. They will come, they will go.
If you like this,
I will soon cut the live stream now. You guys are see the zero people are watching now.
I'm on way to
1 person.
don't tell me that.
2 people.
This is not just true.
If I see this question, I'll just leave it to us.
I will jump. I will not even touch it.
So, actually, you're not crossing anything.
Like, who is Gibat? Gibat. Omo Ike abi. You sabi him?
Give us.
You see that guy who come together? He say Oludare be like one mass lecturer.
Can we finish up?
It's not clear again.
This question, I'm jumping.
We were there, never clear. You want me
This one can integrate this one. Can integrate this one.
I shall do more why integral of the x over 1 plus the s.
What is something like don't chop up? No, I give you chop.
This is like stop mark. Go in theory.
They don't go that mark.
Can I give this one?
Okay, the video. I'm sorry. How far now? Is it clear now?
Oh my God!
We're doing engineering maths.
But wait, why did they give compulsory mathematics? You are not.
Is it all engineering? Is it all
You know Saudi.
There's engineering maths.
Yes, sir.
We did engineering maths exam.
And there is ordinary math.
Oh,
Go picture.
Báwo ni exam? Báwo ni exam?
engineering maths.
To exam tẹ̀ ṣe
This one
lára.
chicken question. This one chicken question.
Reverse one.
This one is
Only is answer. Okay, ṣé G ti tó náà lẹ ṣe lára? Tó náà yẹn òun ló yẹ ó yẹ kí èmi ṣe instead of OD. Tó náà yẹn ọlọ́fà náà. 102 video 102 is gone late below. I want limit it on
It depends. It depends. The man's questions are not.
Okay, we use
I not
No problem. No problem. So if you don't have foreknowledge,
yeah.
you just sit down.
But you
Yeah,
forget.
this is structure, IFTC.
Why
Can I
do
use it? Everybody knows it. Everybody knows it. Please, can I click this?
It's not
Physics is shaking me like this. This Tama physics, like I don't like Tama. Even I also have issue with 10300 level. All I love is vector. Electromagnetism, vector, 102. Those are my best courses. You are in computer science. Paragon for don pour spirit inside you. Paragon don't pass here. The paragon should have poured some spirit inside you. Yeah.
We try.
It's my very close friend. It's my very close friend. Or let me say it was. Like my very close friend.
that a form.
No.
One person watching, okay.
So please, let's worry about it.
Torí ẹ̀ jìyà àwọn ti ẹ̀ dáhùn lọ́wọ́. 0 person dey watch.
0K. Sorry.
Bí 0 ẹ̀ bá wọn bí 10 lè máa wò lọ́wọ́.
I just want 7 part of it.
No, that's right.
Can I see this? Now let's finish this one and integrate it.
I'm waiting for it later. I will do live stream. I will see like 500 people watching.
So please, let's finish this integration. The integration of this one is easier. So let's do this one first. So y equals to integral of dx over 1 plus cx squared. We are going to notice that this looks like arctan. It looks like arctan. So what we are going to do is that we write this as dx over 1 plus cx. I've been taking up to cx squared. So we say let u equals to what? Let u equals to root cx, which means du equals to root c dx, sorry, and dx equals to du over. Do we get what I'm doing? Please, do you get what I'm doing? Root c is a constant. 1 plus, this is my u, 1 plus u. If we integrate it, this is arctan u, right? Standard integral. So I have 1 over root c arctan u, isn't it? Do we get what I did? Which is the same thing as 1 over root c arctan. What's my u? Root c. Let me just say c2. Okay, c is even another constant. So this is the final answer. This is y1. This is the first y that I can get. There are still other y's that I can get, especially from this one. Let's integrate the second one too. Let's integrate the second one. All right. How much?
Should we end the live stream?
My fans.
You go chop your rice now.
Yeah.
Right there.
For this
Rice there.
homogeneous one. Wait, we have not done the second one. Should we do it?
Let's do it together.
Or
That one is common to
I don't write nonsense for this course, I come out and second semester.
You will comment on
Add that.
any exam you have written.
Exam.
I don't want the second semester.
Okay, but if you don't, what if you don't write the exam?
You don't write it.
First
You have to
semester,
show them
second
Jaja why you
semester.
don't write. And Jaja is meeting you accept.
Jaja?
Yes, that's the only thing you accept.
Which
Jaja is the
one?
only reason. Like you are sick, is the only reason.
Wow.
There is this course I borrowed. I thought it's a second semester course, my first semester. No.
Bro. Is he only?
There's one course I borrowed.
He's sick, he's with us.
Structure and bonding.
This time.
The time was
You are
the
there.
time you are doing your exam.
I should be in Nigeria at that particular
Then what's the essence of Adam?
Adam, the second semester.
The need in class.
Don't worry, I'll go visit it. I'll go visit it.
Àwọn course méjì kan tí mo.
Well, actually, I
No,
read
we can't do it again.
I read about it. Our professor was also doing it. He said,
You have carry over in that.
if there's a course that is going to travel,
Yeah, you go and learn it. I'll go and learn it.
My yearly second semester because I thought it's a second semester course I borrowed. No, chemistry for structure and bonding because it's related to physics. While I was going first semester, I wanted to share test.
you have to read it.
My yonder, one kinematic and me tell this touch yẹn báyìí. Eh? There is another math too.
Don't worry, now why not?
Mo máa lọ bá wọn, wọ́n máa bá mi gbayọ mi ò ṣe exam.
So can we start? Please, you understand what I just did? Please. You understand what I just did? On Monday, Jesus.
Kọ́ọ̀sì mélòó mo fẹ́ yọ bẹ́ẹ̀?
On Tuesday, there are two courses there.
Kọ́ọ̀sì mẹ́rin mo fẹ́ yọ second semester.
That one, 2-1, and this makes Jesus.
Mechanics ti wá ya wèrè yẹn.
Can we integrate the second one? Can I get this? Looking at this, see, it's just like this. I want Actan for Actan. Actan, the shape of Actan. Actan X. Actan X is also, if we differentiate Actan, is 1/1 plus S squared. So what I wanted to do here is to make this thing a perfect square. The square of something. So since this one is square already, make this C also in form of a square. That would C squared. I mean, you can see if I open this bracket, the same thing as this. Do you get what I'm saying? So I will say let my u equals to this, let u equals to this thing. Let u equals to root C x bracket. So if I differentiate both sides, the u equals to, this is a constant, equals to dx. You get what I'm saying? The u equals to dx. It's just like saying this is u equals to root cx. The u dx, if I differentiate this with respect to x, is this x will disappear. So that's root c, abi? So it means my du equals to root c dx. What I need is to make this x the solid formula, so I can transform this thing from dx to du. So my dx equals to du over root c. I divide through, abi? So after I do this, the next thing I will do is to write everything here in the form of u, in terms of u. So I will now have something like integral of dx. Instead of writing dx is equal to dividing both sides by root c over root c. It means my dx equals to du over root c, abi? Instead of writing dx, I write du over root c dot 1 over, abi? You get what I'm doing? 1 over 1 plus 1 plus, this is my u. I want to rewrite everything in form of u. 1 plus u squared. But since this one is a constant, I can bring it out. 1 over root c integral of du over 1 plus u squared. Now this is in form of arctan. If we integrate 1 over 1 plus u squared, or 1 over 1 plus anything squared, when both of them are in the same, what's it called? This is u, this is u, this is arctan u. So I now have 1 over root c arctan u plus c. I cannot write my u with u is root c. 1 over root c arctan. Instead of writing u now, I now write root c x and plus. That's what I did. Now let's do the second one. You will see which one carries weight. I can clean everything, Abi. Now for the second one, this time around, we are operating with minus, not plus. So this means our c is. So we are integrating the x over 1 minus cx squared. So what do we do? Make it a perfect square again. The integral of the x over 1 minus root cx squared. Do you get what I mean? Please, do you understand why I'm doing it like this?
No.
No. To make this a perfect square. To make it a perfect square. So what will I now do after this one? This is 1. 1 is always a perfect square. Difference of squares. So I now have the integral of dx over 1 minus root cx, 1 plus root c, Abi? Partial fraction. Thank you. So now have a over 1 minus root cx plus b over 1 plus root cx. If I do this, I now have 1 minus root cx, 1 plus root c.
You can also use tricks now.
Tricks of. Will it work?
No, come on, love.
Let me do it like this. A times everything here. We have a plus cs plus b times everything here. B minus b root cx. Everything here is equal to what? It's equal to 1. Everything here is equal to 1. I don't know what's 1 here. Comparing. This is the constant, this is the constant, it is equal to 1. So a plus b equals to 1. Abi? A root c minus b, a root cx minus b root cx equals what? So it means a root cx equals to b root cx. I can cancel out what, Abi? So what does that mean? It means a equals to a plus b equals to 1. So I can now say 2a equals to 1. Do you get what I did? B is same thing as a. So a plus a is equal to 1. 2a equals to. So it means my a equals to what?
1 over 2.
A is same thing as b, which means b is also equal to.
1 over 2.
Do you get what I'm doing, please? So now let's just plug it back here. Please, you all understand how I do?
Yes.
Do you understand this? Can I clean it? I can clean it, Daddy. So a is 1 over 2, b is also 1 over. So I can now put it here. Since we are integrating, Abi?
Yes.
Since we are integrating, a is 1 over 2, I can bring it outside.
Yeah.
1 over 2 integral of dx over 1 minus root cx plus 1 over 2 integral of b of over 1 plus root cx. Now, we can finish this one up. Can we finish it?
Yes.
Root c. What do we notice?
Link.
It is a link. But if we differentiate this one, what are we going to get?
Negative.
Minus root c, Abi. But this is not. So what do?
Multiply.
We introduce it. Minus root c over minus root c. This one too. Plus root c over plus root c. So this is going to come out and stand here. Minus 2 root c. So this one will stay up. So that if I differentiate everything that is down, it will become what is up. Abi, it will become what is up. So I now have 1 over minus 2 root c ln 1 minus root cx plus this one too. This one too will come out here. 2 root c, Abi, plus 1 over 2 root c ln 1 plus root cx. If I differentiate this, I'll get this.
Yes.
Properties of link. I can bring out, I can factor this one and say 1 over 2 root c into bracket this one minus this one, so that it will become easier. Link. Since it is link, this one minus link, this one, I can write it as link 1 plus root c x over 1 minus root c x. Do we get this? This is the final answer actually. This is the final answer for the second one, or this one that has minus. So this is the integral. This is the final answer as y equals to this. For number 1, that's the answer we can get. The 2 possible answers you can get. This and the first one that we did. I didn't even remember the first one. Y equals to this.
Which question are you solving, sir?
Number 1. 1 over root c after
Root CX.
c x.
Yeah.
So that's everything.
Mo dẹ̀ mọ̀wé ìgbà yẹn o.
You know what we did. Please, do you get what I just did? Do you get? It's just long. It's just long and interesting. It's not like...
You don't want that interesting. You don't want anything like interesting.
Alright. So that's what. So that's for number 1. So if there is no y, the y is missing, we use equals to dy dx. Yv is a function of x.
And this is not compulsory with eating.
If we say
Get your face.
Yeah.
Just some question you
answer like this, I don't know.
Answer any seat.
No, the answer for is really impossible.
It's really aware now.
Answer all.
But there's one thing I heard about. They said command 2 to for last question. So we should try using last question.
Yeah. Even when he taught us 1 for 200 levels, we might pass.
He does a bit down.
Last question.
But it's a new, it's not the same course.
That man is a being
I want to
hand.
experiment on our head. One person must be the scapegoat now. That's good.
So that's all about this. We have integrated it. Should we do this one or should we leave it? Should we do this?
Good night, yo. I know they follow up again.
It's only remains 2 things that we want to do now. Non-homogeneous and operator D.
Let me to know homogeneous and that one.
Should only be first one, you know. Never.
Can I clean this? Please, can I clean this?
When you for guy, when you the job, Shira is on in love.
But I'm doing this now. Please. Please, at this point, I hope you all know that food is just about integration. Food is just about integration. Please, one let me. Okay, for the second one, the square y dx squared equals to the y dx squared plus 2 dy dx. So for this one, we said. So for this one, we say let x be the one that is missing. So it means b is a function of y and it is equal to dy dx. Have it? B is a function of y and it is equal to dy dx. So which means if we differentiate both sides, it will mean the square y dx, the square y dx squared equals to what? V dv dy. Equals to v dv dy. So we are not going to plug it inside. The square y dx squared is v dv dy equals to dy dx is v, abi, v squared plus 2v. I cannot divide it by v, abi. So which means dv dy equals to what? V plus 2. The v over v plus 2 equals to Abi, equals to the y. Integrate both sides. So we have something like y equals to ln v plus 2. Abi? So y plus c. Abi? So it means v plus 2 equals to e raised to power y plus c. V equals to plus c minus 2. I can turn this one to c, abi? I can bring it up. C raised power y. So v is the y dx, the y dx, yes. The y dx equals to c raised power y minus 2. So we can still separate this one again and finish it off and say dy over c e y minus 2 equals to dx, abi? This one, can I write that? Look.
That one was just now.
I'm looking at what I can do to this. Want to integrate both sides.
Another integration.
No. It's all about integration. It's just about integration. This one. CE raised to power 1 minus 2. This minus 2 is the problem.
Guys, you need to make that, Daddy. This is the score.
You know what? To still know. To still know. Woo! I really know about this. No, that's but you can read another thing as a work to do. So I can clean this one now. Second order non-Muji. So that's where we are going to enter undetermined coefficients.
Undetermined coefficient.
Yeah. We are going to use variation of parameters, and we are going to use Euronscan method. But there's one clarification I'd like to make about this one. Variation of parameter is the same thing as Euronscan method, but the way I use it, both of them is drastically different. The way I use both of them is but I'm going to the variation of parameter, I'll follow this like exactly the way they did it, it's like that. But this Euronscan method, I don't even think they did anything like that. But it's good to do it. Come on, you did it.
We don't know shit down, we just like that.
When they shit on
I spent 2 days or maybe I still don't understand.
I'll clean this with this.
Carry on back. I need to drop it. Carry on.
All right. So we have only 3 questions.
I was going to say I did like that tonight. I'm just doing fine.
Or you know what? You know what we are going to do, please? We are going to use only these three questions. Like we solve the three of them using undetermined coefficient. Look, undetermined coefficient cannot work for this. This circuit only works for x, e raised by x, and plus x and sin x. That's what it works for. It does not work for this. Undetermined. So we are going to use the three of them to solve the three of them. So we've also solved the three of them using this one. Solve the three of them using this one. Solve the three of them using this. Can we start? Shall we start? We start. So whenever we have a non-homogeneous ODE, the first thing to do is what? Find the particular solution of the complementary solution, sorry, or the characteristic or whatever of the homogeneous part. So let's do that. So this one we equate it to 0 and say y double prime minus 5y prime plus 6y equals 0. R squared minus 5r plus 6, Abby. Minus 5, minus 2, minus 3. Homogeneous is always equal to 0. Like these three of the first line, instead of they are not equal to 0. They are not equivalent to 0, let me see. So if they are not equivalent to 0, they are not homogeneous parts. This is what is making them non-homogeneous. We understand how we can do this one now? So minus 2 minus 3. R squared minus 2r minus 3r plus 6 equals to 0. R into bracket r minus 2 minus 3 into bracket r minus 2. Have it? So it means minus 3 r minus 2 equals to 0. R equals to 3 or r equals to 2. So y equals to e raised power 2x or e raised power 3x. Isn't it? Do you get? So it means the y equals to the complementary, right? Don't forget this. YC. Our final y equals to YC plus y. Please don't forget that. So YC equals to the addition of these two. C1 e raised power 2x plus C2 e raised power 3x. So these are our y complementary. Now we need the y particular.
Are we using undetermined?
Yes, we want to use that first. We have not started though.
I know.
We have not started. This one is the first thing you have to do. Always find the complementary solution first. The solution of the homogeneous part, always find it first. You know what?
Yes.
Have we? Should we use operator GT?
Whenever you should use this one first.
Okay. Maybe that's also even used for operator GT. Or as it goes, yeah. So let's start, please.
That was simple.
Can I?
Whatever I'm not saying
Go slide for you, another slide. Y is equals to this. Can I continue this?
yes.
Now, undetermined coefficient is that undetermined coefficient, I prefer to call it initial guess method. Initial guess method. So it's just that you guess. It's not really a guess because there is a structure. It's not really a guess, actually. It's not really a guess. Now, this is x squared. If it is equal to x, you are going to add a to this, ax plus b. Turn it into a polynomial, total polynomial. If it's a polynomial like this, turn it into a total polynomial. Like this one now that is x squared, we now turn it to ax squared plus bx plus c. These are y particular. So what we now need to do is what? Find the value of a, b, and c. Do you get it? Can I clean it?
Yes. Do this one, you like your.
So now let's find the value of a, b, and c. Please can someone help me write this? For number 1, yc equals to what? C1 e raised by 2x plus c2 e raised by 3x. So continuing with number 1. Number 1, our yp, our particular y, using initial guess method, is ax squared plus bx plus c, because this is x squared. So you start with ax squared. If it is x cube, you start with ax cube. If you start with ax raised to power 4 plus bx raised to power 3, you will decrease it until you get to the final constant. Now, there are two, the second, this is x squared. So it's going to be ax squared plus bx plus c. If it is x cube, it will be ax cube plus bx squared plus cx plus d. You get? So we are not going to be differentiating until we get. So now this is where we now use our method of our variation of. We are differentiating twice. Why? Because this is the second order. We need a y particular, which is a second order. So yp equals to, let's differentiate this. 2ax, right? Plus bx, plus b, sorry, Abi? Yp double prime equals what? 2a, and that's all. So we are going to substitute into the original equation. Yp double prime is 2a minus 5. What's y? 2a x plus b plus 6y. What's y? Ax squared plus bx plus c equals what? Equals to x squared. Abi? Now let's open the bracket. 2a minus 10ax, Abi? Minus 5b plus 6ax squared plus 6bx plus 6c equals to x squared. So the first thing you do is look at x squared. Compare. Compare. So it means 6ax squared equals to x squared, Abi? You get what I'm saying? The ones that have x squared on this side and the ones that have x squared, you compare them. So it means 6ax squared equals to x squared. So I can cancel out, Abi? 6a equals to a equals to 1 over 6. I got it A. Now for B, let's compare the ones that have x. The ones that have x, let's write them out. Minus 10ax, okay, plus 6bx. That's all. Let's compare the ones that do not have any, the constant terms. 2a minus 5a plus 6c. Now you notice that there is no function of x here. It's equal to 0. There is no constant function here. It's also equal to 0. We have known our a. So I can write this one as minus 10 over 6x plus 6bx equals to 0. I can write this one as 2 over 6, Abi, which is 1 over 3 minus 5b plus 6c equals to 0. Looking at this one, I can divide it by x, Abi. You don't understand what I'm doing? So it means 6b equals to minus 10 over 6, Abi. B equals to what? Minus 10 over 36. Abi? I've gotten A, I've gotten B, which means 6.
Is it minus or plus?
Oh, minus is coming to the other side. Thank you. It's coming to the other side. 10 over 36. Oh, thank you so much. Now for this one, 1 over 3 minus 5, what was B? 10 over 36 plus 60. 6. We don't know C. Equals to 0. 1 over 3 minus 50 over 36. So I can turn this one to times 12 over 12, Abi. 12 over 36, Abi. 1 over 3 is still the same thing, Abi. So I will join both of them together, please. Plus 60 equals to 0, Abi. So this will give me something like minus 38. If I join it, 12 minus 50 is minus 38 over 36 plus 60 equals to 0. So I can say 60 equals to, bringing this one to the other side, minus 38 over 36. I can reduce this. 2 here 19, 2 here 18. So C equals to what? Minus 19 over, oh, thank you. 19 over 18 times 6, what's 18 times 6 please? 60 plus 48, 108. So that's 19 over 108. So that's C. So you have gotten A, you have gotten B, you have gotten C. So our YP equals what? Y particular is now equal to A S squared. What's A? 1 over 6. 1 over 6 A squared plus what's B? Bx. B is 30 over 36. I can reduce this to 5 and 2 we go. 5 over 18. Have it? 5 over 8 plus C. What is C? C is 19 over. And 19 going 1 8. 19 times 9. Ah, no. No, 9 cannot go in. 19. 19 is a prime number. 19 is a prime number. Plus 19 over 108. And these are our Y particular. I mean, these are Y particular. So, Y, the final Y for number 1, the answer is now equal to YC plus YP. So, Y equals what? C1 e raised to power 2x plus C2 e raised to power 3x plus 1 over 6x squared.
Oh my God.
Plus 5 over 18x plus 19 over 108. So this is initial guess method. Initial guess method or undetermined coefficient. So this is the method of undetermined coefficient. Initial guess method. So this is the final answer. From this, you know how I differentiated this. So I start with this. This is it. After differentiating everything like this, I will now take everything back into my initial equation. Initial equation, this one. Y double prime. Y is now functioning as YP. So everywhere I see YP, I take it as Y. Do you get it? Now, starting with Y double prime, I go to YP double prime. 2A. You write it instead of this. 2A minus 5 was Y. So you input it into the bracket plus 6 initial Y is equal to this. Is equal to that. So you are now going to compare. Open the bracket. After opening the bracket, I have 2A minus 10AX minus 5B plus 6AX squared plus 6BX plus 6 equals to S squared. So everything you are left to do now is compare. Which ones have S squared? Which ones don't have? This is 6A squared. This is S squared. So it means 6A equals to 1. The coefficient of this X squared is 1. The coefficient of S squared here is 6A. So it means 6A equals to 1. Do you get it? So here it means A equals to what? 1 over 6. I've got it A. Now you are going to establish another equation for the ones in terms of X. This one is for the ones in terms of X squared. For the ones in terms of X, write them out. Minus 10AX plus 6bx. There's no term of x here, so it is equal to 0. Do you get it? Equals to 0. So I cannot divide it by x and say minus 10a plus 6b equals to 0. But note, I found a is 1 over 6. So I cannot put it inside. That's what I did here. Minus 10 over 6. A is 1 over 6. Sure, you get it? So it means minus 10 over 6 plus 6b equals to 0. Do you get it? I cannot bring this to the other side and say 6b equals to what? 10 over 6. Do you get it? So I can now isolate b and say b equals to dividing both sides by 6. 10 over 36. Do you get it now? You have gotten a, you have gotten b. I can simplify this one to 5 over 18. This one is from this one. From the third equation, the ones that are linear in constant. The ones that are just constant, pure constant. So they are now going to become 2. What is A? A is 1 over 6. 2 over 6. That's where I got 1 over 3. You get? 1 over 3 minus 5b minus what's b? 5 over 18 plus 6c equals to 0. You get? So it means 1 over 3 minus 25 over 18 plus 6c equals to. Now these are the two constant terms, Abi. This is 18. 3 is a factor of 18, Abi. So I can write this as instead of 1 over 3, 6 over 18. It's still the same thing of 1 over 18. So I can now do 6 minus 25 minus 19. Yes. Minus 19 over, is it 19? Which one is 60?
6 years for the last time from this one.
Minus 19 over 18 plus 60 equals to 0. I mean, do you get what I'm doing?
Like times.
So it means 60 equals to, this one comes to that side and become plus 19 over 18. It means C equals to, I'll divide this function by 6. So that's 19 over 18 times 6. This 60 plus 48, 108. So it means C equals to what? 19 over 108. Do you get it? So we now write y. We have no A, we have no B, we have no C. So that's everything we need to do. But note, please, undetermined coefficient is not normal for So, should we use relation of parameters for number 1? Yeah. So, we are now going to look at which one is the best method. Which one is the best method that we have seen? That's one of the easiest. That's long. Wait. Is this thing showing? Is that down one? Is it showing? It's showing, Abi. Join us. Can we continue? You are a little bit confused.
Yeah, I think the way you arrange it here, is that the confusion?
You first, you know I did everything here.
So that place is set up so I think the confusion is around you. The way you arrange, maybe she help us to like
Start from there.
yes.
So this is what I basically did. Always do something like this. First, after opening everything, first write out the ones that correlate with the x squared. This is the highest one part that is there. So write it out as 6a x squared must be equal to x squared. Now let's go down with it. The ones that are in x minus 10ax, the ones that are in x plus 6bx, that's all. Equals to, there's no function of x here, which is equal to 0. So I can divide this one through by x, Abi, and say minus 10a plus 6b equals to 0. Or say 6b equals to minus 10a. Abi, correct? Now let's look for the ones that are independent of x.
Since that they move to that side, it should not be minus again.
God, Jesus Christ. Simple mistakes. Little mistakes are not that.
Scholars, man.
Sorry, please. So that's 10a. Abi?
Yes.
Now, the ones in terms of the ones that are just constant, let me just say that. So we have 2a, the ones that are just constant, minus 5b plus 6c. There's no constant here, so it is equal to, it's also equal to 0. So those are the systems of equations we have. Systems of differential equations.
Yes.
Systems of differential equations. X dot.
I don't
go to class.
I think you will sit down the back because the place of phone.
System of equations.
This is what
X dot plus y dot equals to 6. And they will give you another one like x y dot plus y dot
This is like what they talk about. They teach you like this one.
Which one? This one. This one.
Let me check.
You know how to go by just put down
I think you know the same.
So can we continue? You can finish it up, Abi. You can finish it up.
Continue, sir.
You just go.
Okay, do you have to talk like
So we are gotten this as 6ax squared equals to x squared, Abi.
Yes.
Cancel, Abi. 6a equals to 1. A equals to what? 1 over 6. We have gotten our a. So using this, you can now say 6b over 6. That's 10 over 6, Abi. Divide both sides by 6 times 1 over 6, Abi. B equals to 10 over 36, which I can simplify to 5 over 18. So that might be, Abi. So the third one, I can now have 2a. 2 in bracket, what is it? 1 over 6 minus b is 5 over 18 plus 6c equals to 0. This 2 here, 1, 2 here, 3. 1 over 3 minus 25 over 18 plus 6c equals to 0. Abi? So I can now say this one 6 over 18 is the same thing, Abi. 6 minus 25 minus 19 over 18 plus 6c equals to 0. So 6c equals to, this one will come to the other side and become 19 over 18. So basically c equals to 19 over 18 times 1 over 6. 18 times 6 is 108. So we have c equals to 19 over 108. And that's all. We have found a, we have found b, we have found c. Please, if you don't understand, let me know, please. Now let's go to variation of parameters using the same question. Variation of parameters using the same question. Wait.
No, that water. It's not those
This one here.
Equals to 0.
It's not those ones, so I'm done with those.
So this is
I think variation of parameters is there. Let's do it. You are going to judge. You are going to judge them.
Where is the final solution?
This is final y. This is my y of p, my particular y. Particular y.
The left side to come. Avila.
I want to know that what this.
This thing is that. This is that.
You need to find something to
For it.
Yes.
Hey,
Jesus.
I'm going to
That was my one challenge.
For it, it's not supposed to be a challenge. Maton 2 is not.
No, that's not my thing.
You got it, that's
Social
right.
relation was a long time ago.
Maton 2 is just based on 3 parts: limits, differentiation.
now.
Limit simple. Limit is there.
You use limits in 2 over.
Integration. That's all.
Limits here. So it doesn't
Oh,
matter.
limit is just you know go value. Limit
You
no
don't
go
tell
value.
my thing is the
If na you give limit, you go know that you go value. Maton 2 was crazy last. It's always crazy. It's not crazy. But these 3, you can finish the 3 of them within 1 week. For it. The worst part of this is limit. Either of these together. Differentiation, even you can finish differentiation in 1 night. It's not hard at all. You can finish it. But integration, if you come to place where you have to use fixed or is that substitution problem. The worst part being always trust. Jesus. Let's continue.
Let's rush it.
Let's see equals to x over 2. Variation of parameter, I can change it now. So variation of parameter does not use anything that relates to let's guess, let's do this, let's do that. After variation of parameter, now or after long scan, we are now going to determine which one is the easiest or which one is the fastest. I just hope we get the same answer so we're not gambling on where we make mistake. So for number 1, we have gotten our y1 equals what? E raised to power 2x, and our y2 as what? C2 e raised to power 3x. So variation of parameters say that it says that let us just have a y. Let us just have a y, which is like a complementary solution. But this time around, this C1 and this C2, replace them with K1 e raised to power 2x plus K2 e raised to power 3x. So the difference now is that K is not a constant, it is also a function of x. That's the difference now. Y equals to K1 e raised to power 2x plus K2 e raised to power 3x. So you have to, so as not to give yourself problem later on, we have to establish equation K1 prime e raised to power 2x plus K2 prime e raised to power 3x equals to 0. We must establish this. In essence, K1 prime y1 plus K2 prime y2 equals to 0. Then for this one is for second order. For second order, that we are doing like this: K1 prime y1 plus K2 prime y2 equals to 0. Then K1 prime y1 prime plus K2 prime y2 prime must be equal to your R of, should be equal to your R of x.
So which one is
You don't need this. You don't need this. This is what we are going to solve later on our simultaneous equation to get our y. But if it is a third order equation,
You said the second one is for second order.
yes, the
So
second
we are
one
in
is,
second order. Are you not in second order?
yeah, we are going to, yes, I know. If it's a third order, this one will be equal to 0. We will also establish this one as equal to 0.
Function of R.
So
If it's a
our
third
Rx is
order,
now
okay, we are in second order now.
our Rx is now what?
Rx is always this one.
Okay.
The one that makes that equation.
Yeah.
That's the Rx. So can we continue? Y equals to K1 e raised to power 2x plus K2 e raised to power 3x. K is a function of x. So we have to establish this equation. Establish this equation. Now let's do for the first. Y1, y prime. What's y prime now? K1 prime. Don't forget, K is a function of x. So if you are differentiating K1, it will be K1 prime. K1 prime e raised to power 2x plus 2K1 e raised to power 2x. Do we get how I differentiated this? Product rule.
Okay, yeah. K separate.
Yes.
E raised to power.
Yes. Please, do you get what I did? Differentiation. Product rule.
You differentiate the first.
You did
then,
it. Yes, thank you.
you
differentiate the first, you leave the second one alone.
Then you differentiate the second one.
You differentiate the second one, leave the first one alone. Yes. Yes, product rule. Please, do you get what I did now? For this first part. Now let's do the second part. The second part will now become plus K2 prime e raised to power 3x plus what? 3 3K2 e raised to power 3x. Now don't forget this one that we have established is equal to what? Is equal to 0, right? Y prime as 2K1 e raised to power 2x plus 3K2 e raised to power 3. Do you get what I did, please? To assimilate everything. Please just look at it. Let me explain again. We are using our 2c. Our complementary solution that we got from this one when we made it equal to 0. So we have gotten it like this. So we are going to, instead of writing c1 plus this one, we are going to change c1 to k1. The difference is that c1 is a constant, it's an arbitrary constant. It's anything like 2, 5. You differentiate the constant, it is equal to 0. But this k is a function of x. K is a function of x. So if you differentiate it, it's not equal to 0. It's equal to another function of x. Do you get it? So we have to establish this equation. Please don't forget. Just differentiate these two of them and make it equal to 0. Just try to prime and make it equal to 0, please. So this one is very important. So after we have done that, you are not going to differentiate y prime. What we need is y double prime and y prime, so we can use this equation again. Do you get? So we can use this equation again. So y prime, the first differentiate it. Y prime is now what I got here. Y prime equals to differentiating is I have k1 prime e raised to power 2x using product rule plus 2. You know, if you differentiate e raised to power 2x, you get 2 will come down. 2e2x. Have it? So 2e2x times that k is what give me 2k1 e raised to power 2x. If we differentiate this one, k2 prime e raised to power 3x, k2 prime e raised to power 3x plus this one too, k2 e raised to power 3x. Do you get? So we now have a system of equation here, but not forgetting the imposition that we made. This one plus 1 is equal to 0. It's not compulsory you make it, but to make work easier for you. No, it's compulsory you make it. If you don't make it, you just come to determine method. You're not looking for ABC. So we should make it. So k1 prime, this and this is equal to 0. Do we get this?
Yes.
So if it is equal to 0, I can write my y prime equals to 2k1 e raised to power 2x plus 3k2 e raised to power 3x. You get this?
No.
This one is 0. So I'll just write this out. Please, you get. Ooh. Differentiate again because we are in the second order. Y double prime equals to, first differentiate your k, 2k1 e raised to power 2x, Abi, prime, Abi. You first differentiate this k, then leave k alone and differentiate this e raised to power 2x. If you differentiate e raised to power 2x, you get 2 will come down again with the one that's already there. That's 4 plus 4k1 e raised to power 2x. Do you get it? So I've differentiated this one again. Plus, now let's differentiate this one. 3k2 prime e raised to power 3x, right? Abi?
Yes.
Then if you differentiate e raised to power 3x again, 3 will come down. With the 3 that was already there, that's 9. Plus 9k2 e raised to power 3x. K prime e raised to power 2x plus k2 prime e raised to power 3x. Since this one is 2 and this one is 3, we can't just say it's equal to 0 like that. So what are we going to do? We are just going to put everything inside our equation. We put everything inside our equation. I'm coming, you are going to do it now. So I can clean this, right? I can clean this. Finishing math 2 with we started on the things like that. You know how to generate ODEs from a given constant, from a given function. Let's say I give something like y equals to c1 e raised to power 2x plus c2 e raised to power 2 e raised to power x 2x plus c3 e raised to power 3x. This will be a third order equation. Can you? Okay, let me just reduce it to second order equation. You should be able to do this. The number of arbitrary constants in any function they give you like this is the order, is the number of times and the order of that ODE that you get. So this one now you differentiate it twice and you get the second order ODE. Can you do it?
So you differentiate.
What is
it?
differentiate?
Okay. y prime equals to what? C1 e raised to power x, abi, plus 2c2 e raised to power 2x, abi. Y double prime, because there are two constants we are differentiating twice. Y double prime equals to what? C1 e raised to power x, right? Plus what? Plus 4c2 e raised to power 2x. So the point is about eliminating constants. Subtract, you see that C1 e raised to power x will go. So it means y prime minus y equals to this one will go, this minus this. 2c2 minus is just c2, abi? C2 e raised to power 2x, abi? So looking at it again. If I subtract, let me say the three of it. If I subtract y2 and this, y double prime minus y1 equals to this will go. So this is 2, abi? 2 c2 e raised to power 2x, abi? Which is twice of this. You get what I'm saying? Which is twice of this. That means y double prime minus y prime is equal to 2y1 minus y, abi? You get what I just did? So I can now open this and say y double prime minus y prime equals to 2y prime minus 2y. Bring together what's it called? Y double prime. If this one comes to the other side, it becomes minus. So that would be minus 3. If this one comes here, so this is the ODE. So that's the ODE.
So they give us a question, how us to form the
Yes.
you can use D.
Yeah, you can use the operator. Yeah, you can use the operator. This one is d minus 1. This one is d minus 2. So open the bracket, d squared minus 2 minus 3d plus 2 of y. So the square y is y double prime minus 3y prime plus 2y equals to 0. Exactly 0. That one is the operator. Move. Let's do that one for now. This is chapter 2. Yeah, this is a chapter 2 topic. So please, do we understand the way I've been doing this relation parameters? It looks like the method of initial guess is simpler. Now this one, we are subtracting 5y from it, abi? Let me write everything. Y double prime is what? 2k1 prime e raised to power 2x plus 4k1 e raised to power 2x plus 3k2 prime e raised to power 3x plus 9k2 e raised to power 3x. Abi? So what we are going to do next is subtract this y double prime. Subtract 5y. Where's our y? This is our y. This one. 5 of it. Subtract it from this. So that will be minus 5. 5 times 2. 10. Minus 10 k1 e raised to power 2x, right? Minus 5 times 3 15. Minus 15 k2 e raised to power 3x. Have we? So what next? We are going to add 6y plus 6 k1 e raised to power 2x plus 6 k2 e raised to power 3x. You understand how it did this? So what are we going to do next? Compare this k1, this 10. 10 minus 10 cancels out. Abi? For e raised to power 3x, k2, 15 minus 15 cancels out. Abi? Do you get what I'm doing, please? It's cancelling out. So it means 2k1 e raised to power 2x, there's a prime there, plus 3k2 prime e raised to power 3x. What else remains? Everything else has gone. It's equal to s squared. Abi? Now don't forget the initial, this one that we made. k1 prime e raised to power 2x plus k2 prime e raised to power 3x is equal to 0. So we can now solve this together. So this is very task. So we are now going to solve this together and say k1 prime e raised to power 2x equals to what? Minus k2 prime e raised to power 3x. Abi? Which means k1 prime, or let me just put it inside straight away. This is too long. This method is too long.
So small.
It's done
It's
now.
not confusing when you are doing sine, cosine.
So if I put this inside here, I'm going to get minus 2. Instead of writing k1 e raised to power 2x, I get minus k2 prime e raised to power 3x plus 3k2 e raised to power 3x, right? Is equal to x squared. Minus this plus this, it remains 1. So it remains k2 prime e raised to power 3x equals to s squared, which means k2 prime equals to s squared e raised to power minus 3. Do you get what I did? So we are just going to integrate both sides. So it means k2 equals to integral of s squared e minus 3x dx. So this is integration by parts. So we do integration by parts. Should we finish it? Did you learn integration by parts, please? Oof, let's finish it. Please, do you even understand what I've been doing? It's too long, that's the problem. It's too long, that's the problem. But do you understand what I've been doing? Oof. There's one method, they call it the method. I don't like using it. It does not yield. It does not yield. No, it's for integrating. No. This one, whenever you have a product and you want to integrate the product of two functions that are not the same thing. This is an algebraic product, this is an exponential product. We have a LIATE.
Yes.
You remember this thing? Logarithm, inverse, algebraic, trigonometric, and exponential functions. So that's the order you use. This is algebraic, so is your U. This is your exponential, so is your dv. Yes, udv. By parts, integral of udv equals to uv minus integral of u du. That's formula for integration by parts. But instead of using by parts, some people use magomago. They use a method called DI method. DI method. DI. Differentiate, integrate. So we have the function is s squared e minus 3x. You differentiate this until you get to 0. 2x, 2. You integrate this until you get to whatever. E minus 3x minus e minus 3x over 3. Abi? Plus 1 over 9 e minus 3x. And the last one, minus 1 over 27 e minus 3x. That's integration. Plus 1 over, yes, exactly. So they now start multiplying through diagonally, but it does not always yield correct answer for me. Maybe it's because I don't. You alternate your plus and minus. It's not a normal method. So it's not an original method, so don't use it. The I method. So let's integrate this. At least let's integrate this to get our variation parameter is too long. We are not going to use it again. So, or should we use it for? No, we are not using it. It's too long. Just
From this, abeg.
no, I want to finish it to get my final answer. I want to use it for this one.
No,
Oh, after differentiating this, you understand how I differentiated this. So I now brought it to this place. Y double prime, I wrote it. This one, y double prime, everything. I wrote it. Minus 5y prime. Minus 5 of y prime that I initially did. What was the y prime?
That's 2k. Yeah.
This one.
Yes.
So this is it. So 2k, give this y prime. 2k1, so I wrote it 2. 5 of it. That means times 10 times 5. 5 times 2 is 10.
Yes.
We are subtracting. Minus 10 of this, minus 15 of this. I wrote it, minus 10, minus 15. Do you get it? Plus 6y. Y is k1 e raised to power 2x plus k2 e raised to power 3x. That's y. So plus 6 of this y. So that's plus 6 k1 of this plus 6 k2 of this. Do you get? This y k1 e raised to power 2x plus k2 e raised to power 3x. Do you get? So we now started looking at it. K1 e raised to power 2x, k1 and k1. If you add these two together, that's 4 minus 10. 6 plus 4, 10. 10 minus 10 is 0. You cancel everything out. 6 plus 9, 15. Minus 15, cancel everything out. So everything will collapse into 2k1x plus 3k2. Wait. Okay, yeah, everything is correct. Can I continue?
Yes.
So, what we want to do now is to integrate this to find our k2. So I want to integrate this to get my k2. K2 equals to, when we are integrating this, we use this formula. Integral of u dv equals to uv minus integral of v du. You can cram it, you can write it, you can whatever. So here we are using LIATE. So our algebraic is our u. The one that comes first is your u. The one that comes next is your v. U dv. So this is my u. This is my dv. U equals to what? X squared. So it means the u equals to what? 2x dx. My dv is e raised to power minus 3x dx. So my v is what? E minus 3x over minus 3. Yes. So this is my v, this is my u, this is my dv, this is my dv. So I've listed everything out. The first thing you need to know is your u. Which one is your u? Is the one that comes first in this layout, whatever. This one comes first. So this is my u, this is my dv. Everything here is my dv. With this dx, everything is my dv. So u equals to x squared, dv equals to
2x.
you know I got du now. I differentiated this 2x dx. Have it? So if my dv equals to e minus 3x dx, I will now integrate both sides, which means my v equals to, integrating this one, we have e minus 3x over minus 3 is coming down, which means it must meet minus and 3 on ground, which will cancel it out. If minus is coming down, it must meet minus, which will turn into plus, and it must meet over 3. 3 over 3 is 1, which will cancel it out. That's how I integrated it. You get it? So I have my u, I have my du, I have my v, I have my dv. So now let's integrate it. Equals to uv, u, what's my u? X squared, abi? What's my v? E raised to power minus 3x over minus 3. Minus integral of v du. What's v? 1 over 3. Minus is there, so I can bring it out. Integral of v, e minus 3x du. Du is 2x. 2 can come out, x can come out, dx. We integrate this one in my mouth. Yes, actually. There was one assignment they gave us something like that. We tried. So you will get to a point where you have to represent this one by I, especially if you are using trigonometry. You know trigonometry and sinusoidal, they are returning themselves. You differentiate cos x, you get sin x, sin x you get cos x will give you sin x. You know that kind of return. So you have to replace it with I, so that you just bring just one crazy way like that. It's not crazy at all. So k2 equals to x squared e minus 3x over minus 3 plus 2 over 3. Now I want to integrate this one. My u is x. U equals to x, so it means the u equals to dx. Abi? My dv is dv equals to e minus 3x dx, which means my v equals to e minus 3x over minus 3. Abi? So I can now write it. 2 over 3 UV. What's my UV? U is x. V is e minus 3 x over minus 3 minus integral of VD. V is minus 1 over 3 can come out. So this becomes 1 over 3 plus 1 over 3. E minus 3x dx. Abi? We integrate this one to because it's just so it means K2 equals to don't use gradient parameter. Except if they ask us to. K2 equals to x squared e minus 3x over minus 3 plus you multiply everything here by 2 over 3. So 2 this is minus 2x e minus 3x over 9. This one is coming here which plus 2 over 9. If we integrate e minus 3x, we get e minus 3x over minus 3. So this minus 3 will turn this one to minus. This one can come out and turn this one to 27. You will get what I did, please. You know what? Let me just finish this. 27. So this is my K2. This is my K2. But I'm still looking for K1.
Wait, all these methods now.
So you want to just give us this question?
You should just give up 5
This is what they
hours.
say we should do. That's what
That's what
Yes, no, yeah, I think we should use question.
I knew it was going to go, so I just go. Maybe that is one thing. I use initial guess straight away. I don't waste time. This thing is too long.
Because on one question, you spend 20 minutes, 25 minutes.
Let's use those scans so you can see. So I finish it off, just we have gotten K1, we need to get K2 too. We are going to go through the same process to get K2. So after getting K2, we are now going to write it as y equals to K1 e raised to power 2x plus K2 e raised to power 3x. So since this is K2, now look at this. Look at this. K2 equals to this, Abi. We are going to multiply K2 by e raised to power 3x. So we are now going to get K2 e raised to power 3x. Let me write it here. K2 e raised to power 3x equals to, if I multiply this one by K2 e raised to power 3x, e raised to power 3x, this one will go away. So I have x squared over minus 3. This one will go away. Minus 2x over 9. This one will go away. Minus 27 minus 2 over 27. Can you see K2 e raised to power 3x? That's it. So once we get K1 e raised to power 2x and we add it to it, we are supposed to get this thing back. Should we finish it up, please? Or should we just jump and pass?
Let's jump and pass.
Let's go.
Let's jump and pass. Now look at this Wronskian method. Look at the Wronskian. So we can just jump this one or if you have time for it later, you can do it on your own. Since you have seen how you got K2, you can find K1 on your own and just finish it up. Now look at this Wronskian. Wronskian might be if you can memorize, you can cram, la cram, la pop. You can cram it.
That one will come out.
It should.
Not Russia.
No, we are still going to integrate Wronskian. Now the meaning of Wronskian is Wronskian is the determinant of y1, y2, y1 prime, y2 prime. Do you get how I did this? You just write your y1 and y2, then you differentiate it under. This for a 2-dimension and the second order, this for a second order order. When our y complementary is just 2. So you just write y1, y2. But if it is longer than that, you can have y3. But it is always going to be a square matrix. If this is 3, this one must be 3. So we now have y1 double prime, y2 double prime, y3 prime, y3 double prime. So we now find the determinants. We know how to find the determinants. So since this one is just a 2 by 2 matrix, do you get how I did this one? So since this is just a 2 by 2 matrix, it means the determinant of this matrix. Determinant is this times this minus this times this. So it means W equals what? Y1, Y2 prime minus Y2, Y1 prime. That's our Wronskian. Do you get it? So the Wronskian for this number 1, this is our Y1. Y1 equals to what? C1 e raised to power 2x. You don't need the C. y2 equals to what? E raised to power 3x. Abi? So now let's find the Wronskian. Wronskian W equals to what? What is y1? E raised to power 2x dot differentiate the second one. 3 e raised to power 3x. Abi? Minus what's y2? E raised to power 3x dot differentiate the first one. 2 e raised to power 2x. So what do we get? 3 e raised to power 5x, abi? Minus 2 e raised to power 5x. That's what? Equal to what? E raised to power 5x. So these are Wronskian. That's what? Okay. No, that's not what. W equals to what? E raised to power 5x. So you now cram this thing. Are you done? Can I? So you now cram this thing. Y particular, our answer, straight away equals to minus y1 integral of y2r over Wronskian plus y2 integral of y1r over. So that's our answer. Minus y1. Yeah.
Please. What is the shortcut for cramming?
Just was there.
There should be a shortcut for cramming.
You got that, open your exam.
It's better if you just install that teaching by head.
That would be the best option.
Other people should contribute when I send it to years. Then they will plan So you see, you only contribute when you
So please, you can just memorize this on that. We just plug everything inside. You know.
That our heart is it constant?
No, our these are. Don't forget, these always have. I already continue. These always have. The function at the south side, the function that makes this equation non-homogeneous is the R. Minus y1. What's my y1 now? Y1 is e raised to power 2x. Minus e raised to power 2x integral of what's y2? E raised to power 3x. What's my r? X squared over what's my Wronskian? E raised to power 5x. Plus what's my y2? E raised to power 3x integral of what's my y1? E raised to power 2x dot x squared over e raised to power 5x. Have you? Can I do this? So this one will now simplify to yp equals to minus e raised to power 2x integral of this one will now become x squared e minus 2x dx plus e raised to power 3x integral of x squared e minus 3x dx. So these are the two things you can integrate and that will be our yp. So we're now using integration of parts. Solid. So I'm a fan. Let's see.
That goes for integration. You need to tell me that's one formula for calculating second gravity.
I don't know what's any of this.
We need to be that as well.
There's no other method you can use to solve it. Is there any other?
Someone can create another method.
Okay, actually you can. For real, you can.
Like just moving from one to the other, you need integration.
So after this one, that's everything I read. That's that one is very simple.
System.
Great system.
It's a very simple system of.
System of yeah. You are not doing it. That one is about you never related to time. It's not you are not doing it.
How about converting?
Bros, what's up now? Calm down now.
I did at least 40 in the exam.
40. Yeah, I mean 40, I mean 60. Sit down.
I'm saying let the people go. We're talking about.
People think that
As department is kind enough, we will let it go. Mass department is kind. People really fake mass department, but
some people stick out.
that one is for those. That one is for those. Yes, if you did what they asked you to do, you can't fail it. If you did what
Those
they
are
asked you
the
to do, yeah. If you did what they asked you to do, you will not fail. I like it. So we finish it off. Let's finish it off. So what other? So we have done the three of them. And which one is the best? Have we? Actually, yes, this is the best method. This is the most beginner friendly method.
Which one?
Until you reach this part. Guess method cannot work for this. The only thing guess method can work for is a function x, like polynomial functions, exponential functions, and trigonometric functions like cos x and sin x. It's only these two. It's not work for x. It cannot work for all those.
You see, what's
You can't guess.
another problem in this one?
So what we use for this one is Wronskian is the best to use for this one. Wronskian method is the best to use for this. Wronskian is the best to use for this. Oh. So let me just clean this one up. Or I can write it out and you go and do it. Okay. So this one we are going to enter operator D 13.
I have it here, don't worry.
Okay. Thank God you're writing it. So integrating integral of x squared e minus 3x e minus 2x dx is my UDV. We've done this thing now. We've done this thing now.
Jesus.
UDV. So what's my UV? X squared. My V is e minus 2x over minus 2 minus integral of VD. V is e minus 2x plus 1 over 2x squared. Look, V, the U is going to be 2x dx. I'm coming with this. I just want to. Can you integrate by part, please? Can you integrate by part? I've done it now. What are we doing using this one?
Which one?
Can you put that differentiation? Wait, someone 201 or something like that. This man gave us. I saw directional derivative. She thought
Have you
everything.
done it? Yes.
I'm not doing it for her.
I bet do it. I collect your number, so it's not big.
You have already my number for you. It's like 17 questions.
17 questions. I mean, I will collect your number.
We are sorry consistent. So, using partial integration by parts. There's partial integration too. Integration by parts is once you have these two parts like this, two what's it called? Two functions together like this. So you are going to make one your u following this method, following this one. This is still the most reliable. That's like you don't really need to follow it, but to be causing problem. Why? Instead of this one to be reducing, this one we are integrating this one, it will just keep increasing. It's going to be instead of reducing, we'll be increasing. We want to reduce our problem, we are still increasing it. So that's why we must follow this pattern. So u dv, my u equals to x squared, which means my du equals to 2x dx. My dv equals to e minus 2x dx. So which means I'll integrate both sides and say my v equals what? E minus 2x over, now minus 2 is coming down. It must mean something to counter it so that everything can return back to normal, which is minus 2. The minus comes down, it will cancel the plus. The 2 come down, they will cancel each other. So it's still normal. Do you get what I said? You want to integrate e minus 5x. You want to integrate it, dx. So this will be e minus 5x over minus 5x is coming down. So it must be minus 5 under here. Minus 5 is coming down, so it must be minus 5 under here. Or you can use what's it called? The u method. You can use a substitution method. Let u equal to minus 5x. Do we do it?
What are you trying to do?
We want to integrate e raised power anything x.
I think
This
is
one
part
is
of
okay.
I think
So-
this is part of the loss of integration.
Okay. So let's continue. So we are using u dv minus v du. I've finished. So integral is equal to uv. What's my u? X squared. What's my v? E minus 2x over minus 2 minus integral of v du. What's my v? E minus 2x. Integration, I can bring the constant out of it. So this will turn to plus 1 over 2. Now, what's my v du? This is my v. What's my du? 2x. That means I can write x here and bring 2 out, Abi. So this will cancel each other. Abi? You get? Dx. This is still a product. I use by part again. So this one it is. Let's integrate this one now. So integrating this one, we now have u, these are u, these are v. U equals to x, du equals to what? Dx. Yeah, is equal to 1. Du dx equals to 1. So du equals to dx. dv equals to e minus 2x dx, which means my v equals to what? Integrate it. E minus 2x over. If it is differentiation, minus 2 will just come down. So it will now become minus 2e minus 2x. Down is differentiation. Integration is over. Take this to exponential functions. You want to integrate or differentiate exponential function. Let's say we have a raised power, integrate it. Or no, differentiate it. If you differentiate this one, what do you get? If you differentiate this, you get a raised power x in a. If you differentiate this, you have a raised power x in a. But if you integrate it, you have a raised power x over ln a. You integrate it. There's a lot to learn.
Now that is control.
Okay. Let's finish this. So now let's integrate this one now. We are going to have plus. Now what's uv? U is x e minus 2x, sorry, over 2 minus integral of v du. What's v? E minus 2x over 2 du. V du. What's du? Du is dx. So this is minus 2. Oh, sorry, minus 2. So it can come out as plus 1 over 2. Abi? There was a minus there before, so minus will cancel it out. Please get what I'm doing. So now it means I have this plus integral of this. So it means if I integrate this one, after integrating this one, I have x squared e minus 2x over minus 2 plus integration of this, which is this, x e minus 2x over 2 plus 1 over 2 into bracket. Let's integrate this one now. E minus 2x over minus 2. Abi? So minus this one can come here and turn this one to minus, and this 2 to 4. Abi? Do you get what I did? So this is my integral. No scan. We don't need plus A. Do we need plus C?
Are you done?
Yeah, I'm done with the integration.
When did you start on the
Hmm?
Well, of course.
You are doing row scanning also.
Yeah, we are doing no scan.
Yeah,
So for the
that's
first
not
one,
scanner.
we are multiplying this one to 2 by minus e raised to power 2x. So minus will first cancel this one out. Minus will enter here. This one turns plus. I multiply it by the minus. It makes the e raised to power 2x. So the e raised to power 2x will cancel this. It will cancel this. It will cancel this. You know e raised to power 2x times e raised to power minus 2x is cancelled. So the answer is now x squared over 2 minus x over 2 plus 1 over 4 plus c e minus 2x. There will be a constant for integration. That's the first integration. So we now integrate the second one. So after we do it, we now have to solve them together. Everything will collapse into this. Yes, I'm very sure. Everything will collapse into this. So we are going to get our YP. We are now going to get our YP. And that's question number 1.
Why is it?
Yes.
So after you get the right, you understand what it's going.
After you get YP, just add it to your YC. So the answer will now be Y equals to YC plus YP. That's our Y generally. That's all.
So now, the way it is, like they give you a question.
And they say we should use.
And that's for you to I will just go with it. Forget the game.
If you use Romsky method, it's the same thing as relation parameter. You accept it. Yes.
If you use one more, then you just
Yes, you accept it.
it's relation parameter.
Same thing as Romsky. Yes. But my own methods are
You
different.
get different methods.
Yeah, my methods are different. It's the same, like it's the same method, but there are 3 different methods inside that same method. Actually. So, can I claim it?
Yes.
Operator. After we are done, it's going to collapse. Everything will collapse into this. That one is true. Everything will collapse into this. And so we just add it together. And that's the final
My
answer.
students to get this course.
And that's number 1.
The students, you can drop it with students. You can't drop it with a guy. You don't understand. You cannot drop it. You can drop it.
And you come and take it.
Are you thinking of dropping it? Go to the white and they will explain to you.
So I don't know if you'll be able to.
You can't.
Hey, or-
When there, can't sit down.
No, it's not there. It's right. So overnight, I am available to record everything.
Answer. Which course do you
So
use the country. I was supposed to do the education.
we have tested undetermined
Just
coefficients. Undetermined coefficients. We have tested relation parameters. We have tested Romsky method, and we can see that the easiest one is what? Initial method. It's just it's not everything. It's not going to work for everything. That's right.
This is you. This is not going to tell me.
All right. So using the slide. So this operator, this is our differential operator. This G we call it differential operator. Are you please can you hear what I'm saying? This is our differential operator. It is just operating, it is functioning as any other. The meaning of this D is what? DDX. That's the meaning. DDX. We are inside D operators now, operator D techniques. So it means dy equals what? Dy. Do you get it? If I write D squared, it means what? D squared, dx squared. The second, so if I write D square y, it means D square y dx squared. Now if I write D minus 1 of y, what does it mean? Open the bracket. The y minus y, Abby. Do you get what I'm doing? So it means this is what? The y dx minus y. Do you get now? So that one is just an introduction to. Now look at this function. Let's say we have something like 3 minus 1y equals to e raised to power x. Where inverse operator now comes in is that I can say my yp, my y particular solution equals to e raised to power x over d minus 1. Do you get that? Can you see that? Multiply 3 is just like you are operating with normal mathematics. Can you see that? E raised to power x over d minus 1. If they give you an equation, for example, the ones we were doing before, you can just use this. So we have d minus 1. Why that is, get what I'm saying? So anytime you have something like this now, you are going to use there are 5 formulas you have to. There are 5 like it's a table. You have to. I don't know if it's gram. I will say whenever we have something like this, 1 over d minus 1 and r of x is always e raised power x and they usually use for it. So it's the same thing as saying that e raised power x, e raised power, let's say f, let's replace m with f and 1 with m. Do you get what I'm saying? Let's replace it. So we are going to say e raised power mx integral of e raised power minus mx dot. So this is the expansion. Do you get what I'm saying? So if I want to solve this equation now, so it is equal to, this one is the same thing as saying e raised power x, abi 1x integral of e raised power minus x dot e raised power x dx. Do you get what I did? So we now simplify this and say e raised power x integral of 1. Abi? You see that? So if we integrate this one, what do we get? E raised power x, x e raised power x. You can add a plus c if you want to. Does not really. Abi? Y prime minus y equals to e raised power x, r square minus 1 equals to 0, r square equals to 1, r equals to minus 1, e raised power minus 1, c1 equals to e raised power minus 1, c2 equals to x e minus 1, e minus x. So this is f e raised power x. Particular. C1 y1 equals to, I'm coming with this, e raised power minus x, y2 equals to x e minus x. So if I differentiate, actually I use which one first? E raised power x. Y equals to e raised power x. Where's the relative? It will not be. It will be e raised power x. Either way, this is the final answer. That's the final answer. So that's how we use universal superposition technique. Ooh, so if we are doing, let's say we are doing something like e raised power x over d plus 1. So this one will now be something like e raised power minus x integral of e raised power x dot e raised power x dx. Do you get what I'm doing, please? So you first neglect the, you first, like, you take the negative of the one that is here. E minus x, e raised power x, this one.
Is that okay?
No, this is d, please. Let's say it's d plus 2. So I'll write this as e minus 2x raised to power 2x dot what was on top before. Do you get what I'm doing now? Yes. So we now have e minus 2x integral of e raised to power 3x dx. So this will give me e minus 2x dot, if I integrate this, I have e raised to power 3x over 3. So if this multiplies to, I have e raised to power x over 3. You can add your plus. No, you cannot add your plus. So that's the final answer. Kulofara.
So now, for one that e raised power minus 2, it will be the inverse of what that has been, like for the f.
Okay, yeah. 1 over e raised to power 2x, right?
Like you know that at the denominator is d plus 2.
Yes.
So our m is plus 2 like that.
Yes,
So
exactly.
now once when we are now substituting to minus for the one outside,
Yeah, the one outside will be minus negative of that 2. Let me use another one. Let's see. Please, there are a lot of things you have to memorize in this thing. Please. E raised power x over d plus, let's say d minus 4. Or d square minus 4. So what do we do for this one? You separate it. We now use partial fraction. So this is e raised to power x over d minus 2, d plus 2, right? Do you get what I'm saying? So we can solve it directly by saying, we can solve this directly by saying that we first do 1 over d minus 2. So we first do e raised to power x over d plus 2. Do you get it? Do you get what I just said? So we now do this one. So we now say 1 over d minus 2. So this one will now be e raised to power minus 2x integral of e raised to power 2x dot e raised to power x dx. So that's 1 over d minus 2 of e minus 2x integral of e raised to power 3x dx, which is 1 over d minus 2 of e minus 2x dot, this is e raised to power 3x over 3. If you multiply this together, it's the same thing as e raised to power x over 3. Abi? So this one, we now do it again. We repeat that method. If you don't want this long method, you can use partial fraction to solve this. Or we should finish up tomorrow. We should finish up tomorrow. So I just wrote out the questions for the, what's it called? You can.
Try and attempt it too.
So,
Yeah, I can hear you saying.
so if you use partial fraction to like split now, like split separately for it.
Yeah, you do a separate fraction. Yes. Yes. Should we do it?
Yes.
So we have a over d minus 2 plus b over d plus 2. So this is now ad plus 2a plus bd minus 2b must give us 1 abi. So a and d, all the functions of d are 0. ad plus bd equals to 0. 2a minus 2b equals to 1. Abi? Abi, do you know what I did? A plus b equals to 0. A equals to minus b. So I can put it inside here. 2 minus 2b minus 2b equals to 1. Minus 4b equals to 1, which means b equals what? Minus 1 over 4. Abi? That means a equals to 1 over 4. Do you get that? So I can now put it here and say 1 over 4 over d minus 2 plus b is minus 1 over 4 d plus 2, everything of e raised to power x of e raised to power x. So I multiply it by e raised to power x, and I get 1 over 4 e raised to power x over d minus 2. So you can solve this one, Abi. You can solve this one plus minus 1 over 4 e raised to power x over d plus 2. So you just solve it individually and you add it together. And that's it. What's time on this? 6:10. Ah. Once it is 6:10, should we leave by 6:30 or 7? 6:30. You can let me write this down, please. So I'm going to just explain how we use it, and maybe I can give an example each of them. So this is just about, I'll just give an example here on each of them. So the first one you should know in operator technique is 1 over d minus m of any r of x is equal to e raised to power mx integral of e minus mx r of x dot r of x dx. We're integrating with respect to x. I've given an example of that before. Have you?
You said you substitute minus.
No, this minus m. So the first one you do is being the negative of it, which is plus 1 over it. Now the second one is 1 over 5d. 1 over 5 of d. Now 5 of d is a function of, like let's say we have d square minus d plus 1 of y. Abi, this is a 5 of d, a function of, like it's just like a function of d in y. You get? That's how we write it. A function of d is like a function of y in d, or how should I explain it? Just something like this. So this one like this is also a function of d. If you get what I'm saying. So I can say d minus 1 is a function of d. You get? So this is the second equation you have to do. E raised to power px equals to, this one is used to find, the, what's it called? Very quick. It's a very quick way for finding particular solutions. Is equal to e raised to power px over 5 of p. I'm going to give an example. And your 5 of p must not be equal to 0, please. This first one, this is the second one. The third one, 1 over 5 of d squared, a function of d squared, of course, px plus q, or sine px plus q, the same thing as cos px plus q over the function the 5 of minus p squared. It's looking like magic. Maybe another. Should we do it tomorrow?
Yes.
Will you come tomorrow? Tomorrow. 4. Okay, just 4 over function of d squared of e raised to power px and another function of x, which can be trigonometric. Most times it will be trigonometric. So this one will be e raised to power px 1 over 5 of d plus c of our f of x. So that's the transformations we use in operator. Those are the transformations. I have some questions here. So please write this out. That's what you want to do. So after we can call it a day. Okay, look at this. Let's solve this. This square minus 3d plus 2 of y equals to e raised to power 5x. This is a function. This is already an ODE. You know how we can open it up. So this is y double prime minus 3y prime plus 2y equals to e raised to power 5x. So they say we should solve this. So we now use operator D technique and say y particular equals to e raised to power 5x over d squared minus 3d plus 2. Abi? So for this kind of equation, so we just compare it. So e raised to power 5x, that's e raised to power px over function of, this is what I'm saying, a function of d, a function of d. So here your p is your 5, as it p equals to 5. So p equals to 5. So what you just do is that anywhere you see d here, you just input your p, which is 5. So our y particular for this one is what? E raised to power 5x over 5 squared, which is 25 minus 3 times 5, 15 plus 2. That's e raised to power 5x over 12. That's the final answer. Very serious. This is y particular. Y particular, this is the particular. So you can find the homogeneous C1 and C2, and you have the C3, and that's all. That's what we do. So there's another one here. This square plus 1y plus 2x. This square plus 1 of y equals to cos 2x. So looking at something like this one we can now say yp equals to cos 2x over d squared plus 1. Now this one you now compare it to something like this. So here your d squared, you are going to transform it to minus p squared. D squared equals to minus p squared. So what's your p here? 2 abi? So it means d squared equals to what? Minus 2 squared. That's minus 4 abi? So we are not going to say y of p equals to what? Y of p equals to cos 2x over d squared is minus 4 plus 1. That's what cos 2x over minus 3. And that's our y particular. That's our y particular.
Just need to know this.
Just know this thing. Just know this thing. But this one, if they give us something like this, you are going, should we do this? I have a question. E minus 2x plus 2x, we keep plus 3. This one might be long. But you understand the way you are going to do it. So if you understand the way you're going to use it, you are totally fine with this. dq plus dy e minus 2x plus x. dq plus dy equals to u is for minus 2x plus x, right? Yes. So the first thing you are going to do, using this, e is power px, we are voting our e is power px out. E is what? P equals to minus 2 abi. So the first thing you are going to do is transform it from d squared to d plus p. So anywhere you see d squared, you are going to put d minus 2. Do you get it? So this is now, so this is d plus d. Do you get it? This square, this q is the same thing as this. Let me write this so that you can understand what I'm saying. Y particular equals to e minus 2x plus x over the q plus d. So this yp equals what? E minus 2x 1 over, I will now write this as d into bracket d squared. Anyway, I see this square, I put d plus p. P is minus 2 squared. Anyway, I see this squared. Yes, I just put this. No, you don't need to add this again. Plus d. So our f of x here is cos x. Our f of x here is cos x. So we now open this one and say we have e minus 2x 1 over d squared minus 2d plus d cos x. So we have e minus 2x 1 over d squared minus this minus d cos x. Now this one now we are not going to use this cos x that we've been using. So our p now is now going to be 1. It's now going to be 1. So we are not going to use this square equals what? This square equals to minus b squared minus b squared equals to minus 1. Abi? So anyway we see this square equals minus 1. So we have e minus 2x 1 over this square is minus 1 minus d cos x. So what are we going to do for this one? It's long. It's not long actually. So this one I can now transpose it and I will use conjugate. The conjugate of minus 1 minus d is minus 1 plus d. So I multiply up and down. So I have e minus 2x minus 1 plus d over minus 1 plus d minus 1 minus d of cos x, abi. So I can write my cos x here. Do you get what I'm doing? So this will now be equal to e raised to power minus 2x dot cos x will now, this one will turn to minus cos x plus the cos x means differentiate cos x, which is minus sin x, abi. Minus sin x over here. If I open this, I have plus 1 minus plus d minus d. We cancel out, abi. Minus d squared plus 1 minus d squared. Now don't forget my d squared is what? This minus 1, abi. So this square I can rewrite it as minus 1. So that's minus 1, that's plus 1. So you just finish it up like this. So we have e minus 2x into brackets minus cos. So I can bring minus outside. Minus cos x plus sin x over 1 plus 1, 2. And that's the final answer. And that's the final answer. It's not like a really good one. So just know these formulas. Once you know it, it's not very good. I'm waiting tomorrow.
Thank you, sir.
Okay. So you need so that brings us to the end of today's session. Phew.
This is only judge that can make things honest.
Oh, chin.
That's just a good answer. What is going on?
We have come to the end of today's class. So you can. One more 3 hours. 3 hours, 2 minutes. Is that 3 hours? So I think that's even what questions I have. You can go for square. I'll wait for you.
What time is it? So every Sunday.
So,
So
I'll do that one. So what that means is just different equation of again vector. Please, if you have just slide on again vector, please abeg. Please.
Ah, no, no, no.